Good afternoon, students, and welcome to Q&I summer course. Students, first of all, I'll introduce myself. So, I am Sunit Kumar, and I'm your mathematics tutor student. And we started with the first chapter, real numbers for class 10th, and we did, we started with fundamental theorem of arithmetic, and then we did, LCM and HCF using prime factorization. And in today's class, we'll talk more about application of LCM and HCF, problems in real life. Okay, so we'll do more of word problems and questions which are related to real life problems based on LCM and HCF using prime factorization. Okay, so let us begin the class. And before I start the class, I had given you a homework to practice on the platform on a topic. How many students have practiced on the platform yesterday? Ragul has practiced, and Ragul and Ragvi, have you not practiced? Okay. So, and others, why have you not been able to practice? Okay, Ragvi, we'll get back to you in on how to log in on the platform. So someone will help you in logging in on the platform. And students who don't have their login ID, as Devi Maya is writing, we'll get in touch and create the login ID and password for you. And so that you can first take the proficiency diagnostic test on Friday and Saturday at 11:30 a.m. And once you have taken that test, we can start with the practice of on the platform. Okay. 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 Let's start the session, students. So as I said, we are continuing with the chapter real numbers, and prerequisite for today's class would be to know the prime factorization of a number, how to prime factorize a number, how to find the HCF and LCM of a number, right? So this we have already covered this portion in the previous two classes. Now in today's class, what we are going to do, student, is we are going to again discuss use finding HCF and LCM in applications, application based questions, or word problems based on HCF and LCM of two numbers, finding HCF and LCM of two or more numbers. Now we'll begin with this question, student, today. So because I have given you a basic of HCF and LCM, how many students are attending today's class for the first time, means mathematics class for the first time? Is there someone who is attending the class for the first time? So you all know how to find HCF and LCM. First of all, before attempting this question, who is going to tell me how to solve this question? I'll read the question for you. The smallest number which when divided by 17, 23 and 29 leaves a remainder 11 in each case, right? So what is that number? How to find it? Yeah.
We have no fucking clue.
You can, yeah, you can.
I don't know, sir. Sorry.
Okay, 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 Jovin. So anyone else who want to answer on how to find the answer to this question? What are you going to do? What is the approach of solving this question?
Sir,
Yes, Ragul.
sir, we should subtract the remainder with all three numbers, sir. Subtract 11 by 7. Subtract 11 in 17, 23 and 29. After that, we should find the LCM of the subtracted numbers with the subtracted numbers.
No, Ragul, think about it once again. You have to subtract, but not with these numbers. See, the question says the smallest number which when divided by 17, 23 and 29. So that number which when divide, which is the number which is exactly divisible by 17, 23 and 29? Which is that number which is exactly divisible? If you had to find a number which is exactly divisible by 17, 23 and 29, how will you find that? You will find that by finding an LCM of 17, 23 and 29, because that number which when divided by 17, 23 and 29, it should be exactly divisible. So that will be the LCM of 17, 23 and 29. It is a bigger number, right? As I told you in the last class, whenever you have to find a number bigger number than what is given, you have to find the LCM. So because that number has to be divided by 17, 23 and 29, that's why it is bigger than each of these numbers 17, 23 and 29, and hence that is the LCM of 17, 23 and 29. Now you have to find that number which leaves 11 as remainder. So that means you will find the LCM and then add 11 to it, because LCM will be exactly divisible, but if you add 11 to it, that number when divided by 17, 23 and 29 will always give 11 as remainder. Is the question clear? Ragul, you have understood? Because understanding
Yes,
the question is important first and then solving it. So once you have understood the question, the approach, now after that it is mere calculation. Let's start it. So in this question, student, what we have to do, as I said, we have to find a smallest number which when divided by 17, 23 and 29 leaves remainder 11. So the smallest number which is exactly divisible by 17, 23 and 29 is LCM of 17, 23 and 29. Okay. Yes, Raghavi, the answer is correct. It is option B. Good. Ragul is also correct. So LCM of 17, 23 and 29. So we know that because these are prime numbers, the LCM of 17, 23 and 29 will be just the product of 17, 23 and 29, right? So because by prime factorization, we know 17 is equal to 17 to the power 1. 23 can be written as 23 to the power 1 and 29 as 29 to the power 1. So here LCM will be equal to 17 into 23 into 29. You have to multiply all the factors with highest power. So if you multiply 17, 23 and 29, you will get 11339 as your LCM, right? So now once you have got the LCM, you have to find a number which leaves 11 as remainder. That means to find that number, the required number is equal to LCM of 17, 23 and 29 plus of 11. So this is 11339 plus of 11. So this is 11350. So option B is the correct option here. 11350. Is it clear? Students, is it clear? You have understood the concept? So everyone needs to respond. So if only 2 students respond or 3 students respond, that doesn't give a very nice, feel in the class. So if you have understood the question, so always interact, always try to give in your feedback that you have understood it or not, so that, if you have not understood, we can help you understand the concept again. Okay. Okay, good, Alan. So let's move to the next one. find the largest number which on dividing 1251, 9377 and 15628 leaves remainder of 1, 2 and 3 respectively. Now again, you have to tell me the approach here. How do you solve this question?
Sir,
Yes. Right.
sir, first we have to subtract 1 from 1000 to 51 and 2 from 9377 and 3 from 15628 and you will get 3 numbers. So we should find HCF of those 3 numbers.
Very good. Very good. So the question was, find the largest number which on dividing 1251, 9377 and 15628 leaves remainders 1, 2 and 3 respectively. So to find that largest number, what we'll do is that let us find, if I subtract 1 from 1251, I'll get 1250, which will be exactly divisible by that number. Similarly, if I subtract 2 from 9377, it will be 9375, which again is exactly divisible by that number which we have to find. And if we subtract 3 from 15628, we will have 15625, which again is exactly divisible by that number which you have to find. So a number which divides these number 1250, 9375 and 9375 and 15625 would be the HCF, right? We have to find the largest such number. So that will be the HCF of these three numbers. So let us start the question. So first of all, what we'll do, we'll find a number which is exactly divisible by that number. So 1251 minus 1, we will get 1250, right? And then we have 9377 minus of 2, because 2 is the remainder here. We will get 9375, and 15628 minus of 3 is 15625. Now these are the numbers which are exactly divisible. Why will they be exactly divisible? Because I have subtracted the remainders from that actual numbers to get those numbers which are exactly divisible by the number which you have to find. So here you can find the largest number which on dividing 1251, 9377 and 15628 left remainder 1, 2 and 3. So I have subtracted the remainders from the numbers to get the numbers which are exactly divisible by that number. Now, so the number which exactly divides these numbers, the largest number would be the highest common factor. Okay. So largest number which divides 1250, 9375 and 15625 is the HCF of 1250, 9375 and 15625. Yes, Raghavi, correct. Devi Maya, you are also correct. Okay. So if you have to find the HCF by prime factorization, let us find the prime factors here. So 1250, the prime factors, you will divide by the smallest prime number 2, you will get 625, and then 5 you will get 125, again by 5 you will get 25, 5, 5 and 5, 1. So 1250 can be written as 2 to the power 1 into 5 to the power 4, right? Then 9375 this can be divided by 3. So this is 3125. Then by 5. So you will have 625. Again by 5. You have 125. 5 and 25. 5 and 5 and 5 and 1. So this is 9375 is equal to 3 to the power 1 into 5 to the power 5. Now, we have to find the prime factorization of 15625. So you divide by 5 because it's not divisible by 2 and 3. So 3125, again 5. We have 625, divide by 5, you will get 125, 25, 5 and 1. So this is 15625 is equal to 5 to the power 6. Now to find the HCF, what we do is we find the common factor and the smallest power. So common factor is 5 and the smallest power of that is 4. So HCF is 5 to the power 4, which is equal to 625. So 625 is that largest number, which when divides 1251 will give a remainder 1. When it divides 9377, it will give us a remainder 2. And when it divides 15628, it will give us a remainder 3. Is it clear, students? Have you understood the concept here? So HCF and LCM, to decide that, you should understand that if we have to find a number which is greater than all these three, you have to find the LCM because it will be a multiple of these numbers. And if we have to find a number which is smaller than the numbers which are given, so for example, in this question, it is mentioned find the largest number which divides 1251. So a number which divides 1251 would be smaller than that. And that's why you have to find the HCF here. And the remainder thing, you have to keep it in mind that if there is a remainder, if I remove that remainder, that will be exactly divisible. Is it clear? Okay. So let's go to the next question, students. So the next question is, find the greatest 6-digit number exactly divisible by 24, 15 and 36. Again, before we start the question, you need to tell me the approach here. You have to find the greatest 6-digit number exactly divisible by 24, 15 and 36. What will you do here? I want others also to respond. Don't worry even if it is wrong. We are not here to judge you, right? You will grow in confidence if it is correct, right? And even if it is wrong, I'll help you to understand it. It is very important for you to build that confidence.
Sir?
Yes, Raghu.
Sir, first we should know the greatest 6-digit number, sir. Sir,
what is that greatest 6-digit number?
Say, 6 times 9, 9, 9, 9, 9, 9. So
yeah, 6 times 9.
We should find the LCM of 24, 15 and 36, sir. After that, we should divide the LCM with that greatest 6-digit numbers.
Yeah. So if we have a remainder there, right? So what we'll do is that we'll subtract that remainder so that we get the number which is exactly divisible.
Yes, sir.
Yeah, very good. Very good.
Very good. Very good.
So, okay, students, let's proceed with the question. So find the greatest 6-digit number exactly divisible by 24, 15 and 36. What we are going to do is first find the greatest 6-digit number. So the greatest 6-digit number is 999 and 999, 6 times 9. This is the greatest 6-digit number. Now, if you add 1 to it, it will become the smallest 7-digit number, right? So this is your greatest 6-digit number. You cannot have a number greater than this, which is a 6-digit number. Once you have got this number, now you have to find that greatest 6-digit number, which is exactly divisible by 24, 15 and 36. For a number to be exactly divisible by 24, 15 and 36, it should be either the LCM or a multiple of that LCM, right? So what we are going to find is LCM of 24, 15, and 36. So for this, we'll do a prime factorization of 24. So 2 times 12, 2 times 6, 2 times 3, and 3 times 1. So 24 is equal to 24 is 2 to the power 3, 3 to the power 1. And then 15 can be written as 3, 5 and 5, 1. So 15 is equal to 3 to the power 1, 5 to the power 1. And 36, if you find the prime factorization of 36, 2 times 18, 2 times 9, 3 times 3, and 3 times 1. So this is 2 square into 3 square. So this is 36. Now if we have to find the LCM, student, so how do we find the LCM? Is we take all the factors and the highest power of that. So 2 highest power is 3. For 3 the highest power is 2. For 5 it is 1. So if we find this, so we have 8 times 9, 72 into 5 is 360. So 360 is the LCM of 24, 15, and 36. Okay. So now if we have to, find the number, greatest number, we will divide 999. Let us divide it by 360 and find the remainder. So first 2 times you will have 720, right? So you have 9, 7, and 2. So now here, if I do 7 times, we have 2520. Again, 7 times, we will have 2520. Right? So this is your 4th, this is your 5th, and this is your 6th. So again, you will have 2520 and you have 279 as your remainder. So final remainder is 279. Right? Now, to get that required number, the required number is equal to, we will subtract this remainder 279 from this greatest number. Okay. So when you subtract this, 9 minus 9 is 0, 9 minus 7 is 2, 9 minus 2 is 7, and then we have 39. So 999,720, this is this required number. So this is the greatest 6-digit number, students, which is exactly divisible by 24, 15, and 36. What we have done is, because the LCM is that number which is exactly, so this is the least common multiple. So least number which when divided by 24, 15, and 36 gives you 0 as remainder, which is exactly divisible. So now we have divided this greatest number, 6-digit number, with the LCM, and the remainder which we got, that is 279 here, we have subtracted this remainder from this greatest 6-digit number to get a number which is exactly divisible. So this number is exactly divisible by 24, 15, and 36. So this is your greatest 6-digit number. So greatest 6-digit number, which is exactly divisible by 24, 15, and 36. Is it clear, students? Have you understood the concept here? So these are the questions, which are a bit tricky, right? So these are not straightforward application of HCF and LCM you will find in the books. So these are a question which are a bit tricky. So if you understand these concepts, it will be easier for you to score full on full in mathematics in class 10th. How many students have kept a goal of scoring full on full in mathematics in class 10th? How many students? You can raise your hand. Only one, two. So we have 6 students, out of which only 2 is thinking of scoring 100. What about others? Why do you have a doubt? Okay, 3 people now. Why do you have a doubt that you will not be able to score 100? First step of scoring 100 is to have a goal for yourself that you will be able to score 100. 4. I need 2 more hands. Alan and Jovin, waiting for you. Jovin is also raised hand. Alan has also raised hand. Very good. So I want every one of you, all 6 students, to go ahead and score 100 on 100. Right? We have whole year to do these problems, revise it. Right? So what does it take to score 100? Is to know everything first, to understand all the concepts, and to be able to solve all the questions correct in the exam. So, first 2 things depends on the lectures which we give, the way we explain you. The third thing depends on the practice which you do on the platform. So practice which you will be doing, more you practice, more confidence you will gain in, and then it will be easier for you to score 100 in exams. Okay. So that's why, the teaching only is not enough. It's about practice. It's about platform practice. So more you practice on the platform, you have better chance of scoring 100 in your exams. Okay. Let's move ahead, students. So has everyone written this? I'm sure you are writing it in your notebook and making a note of all the questions which we are doing, because it will help you create a repository of all good questions in your notebook, so that when you have to revise, you don't have to go and see 10 different books. So all these questions are taken from different places and different books, right? So, you don't have to revise every other book or every other place. So this will be handy for you, right? Okay. Now, students, you have to attempt this question on your own and let me know the answer. 3 bells rings at interval of 6, 12, and 18 minutes. If all the 3 bells rang at 6 a.m. together, then when will they ring together again? So once it rang at 6 a.m., all of them together, when will it ring again together, all these 3 bells? Ragul, think over it once again. What is LCM of 6, 12, and 18? See, knowing the answer is one thing, solving it correctly is another thing, right? So first read the question properly. Do check your calculations once you have calculated it, so that if there is a calculation mistake, you can correct yourself. What is the LCM of 6, 12, and 18? Ragul and Raghavi. Yes, 36. Good. So let us check it, student. Okay. So yeah, you are correct, Ragul and Raghavi. Your answers are correct. So 3 bells rings at interval of 6, 12, and 18 minutes. If all the 3 bells rang at 6 a.m., then will they ring together? When will they ring together again? So because again, here they will ring together at a time which is more than 6, 12, and 18. So that's why we are finding the LCM here, right? So LCM of 6, 12, and 18. So first find the prime factorization here, 2 to the power 1, 3 to the power 1. 12 is 2 to the power 2 and 3 to the power 1. And 18 is 2 to the power 1 and 3 to the power 2. So the LCM of 6, 12, and 18 is equal to, so we take the highest power of each of these factors, 2 square and 3 square. So 4 times 9 is equal to 36. Okay. So that means, because the least common multiple is 36 minutes. So these bells will ring again together after 36 minutes. So once they have done it at 6 a.m., next the bells will ring together again at 6:36 a.m. So you are correct. Okay. Raghavi, Ragul, many of you have answered. Jovin, very good. Is it clear, students? Have you understood the concept now? Okay, let's go to the next. Let's go to the next question, students. So the next question is, what is the smallest number that when divided by 35, 56 and 91 leaves remainder of 7 in each case? This is similar to the first question which we did, where we had, remainder of 11 in each case. So what is the smallest number that when divided by 35, 56 and 91? So it will be a number which will be bigger than 35, 56 and 91. So that means, what do you have to find here? Who is going to tell me?
So find the LCM and we should add 7 to it.
Very good. Find the LCM and add 7 to it. So quickly do it and let me know the answer. You have to find the LCM and add 7 to it. So students, find the LCM of 35, 56 and 91. Once you have got that LCM, you have to add 7 to it. Then you will get that smallest number, which when divided by 35, 56 and 91 gives 7 as the remainder in each case. Okay. So the prime factor of 35 is 5 to the power 1 into 7 to the power 1. 3647 is the correct answer, Raghu. So 56 is equal to, I can write it as 2 to the power 3 into 7 to the power 1. 91 is 7 to the power 1, 13 to the power 1. So LCM of 35, 56, 91 is equal to all the powers, all the factors with highest power, 2 cube, and then 5 to the power 1, 7 to the power 1, and 13 to the power 1. So we have 8 times 5 is 40 into 7 is 280 into 13. So we have 3640. So 3640 is the LCM of these numbers. Now we have to find a number, which has a remainder of 7, right? So the number, smallest number, which when divided by 35, 56, 91 leaves 7 as remainder will be equal to the LCM 3640 plus of 7. So LCM plus of 7. So this is 3647. So 3647 is that number. Very good. Most of you have got the correct answer. Okay. Now students, what I'll do is I'll quickly take you to the platform so that you understand how to practice on the platform. Okay. So you can see here, students. So when you go and log in on the platform, you have to, go to the dashboard. So dashboard will open for you when you log in on the platform. Once you have reached the dashboard, you have to click on the assessment, which is on the left side. Go on practice and click custom practice here. Now there are 3 subjects: mathematics, science, and social studies. Since we are doing mathematics, you will go down, right? And you will find real numbers here. Now this is the chapter. Now go in topics, view topics. Now, as I said, in the previous class, I gave you an homework of explain the process of calculation of HCF using prime factorization. Now, in today's class, the homework is to calculate LCM using theorem, right? So you have to do this, calculate LCM using theorem, okay, in today's class as homework. Is it clear, students? Okay, so today's homework on platform is to go and practice. So when you will select the students, you will go on practice for selected topics. So you will have a 30 minutes of adaptive practice session where you will practice the question on that particular topic, that is LCM. And once you have completed this 30 minutes practice, you can submit your practice session and look at your how many correct and how many wrong answers you have given, and try and attempt at least 20 questions in this 30 minutes. So upper boundary is not limited. You can go ahead and practice more than 20 questions as well. You can practice 30, 40, whatever number of questions during that 30 minutes. But do practice of 30 minutes of maths and 30 minutes of science daily during your summer course. Okay. Platform practice will help you understand, what are your strength areas, what are your opportunity areas, how much you have understood that particular topic, so that if it requires a revision of that topic, you will do that revision again. Okay. So this is it for today's class, students. And as I said, those students who do not have their login created on the platform, please write your name on the chat box so that we can get in touch with you, create your login ID and password, and help you take your proficiency diagnostic test on Friday and Saturday at 11:30 a.m. And then we will, then from next week, you can start practicing on the platform. Okay. So thank you, students. Thank you for joining in. Bye and have a very nice day.